text is a phrase or sentence fragment. And what it tries to do is predict what is the next word. And so the early generations of large language models were trained as follows. We would download tons of text, from Wikipedia, from other places on the internet, and then given tons of text, usually download from the internet, sometimes from other licensed sources, the system will see lots of phrases like, my favorite food is something. And based on the statistics of what it saw, whenever there's my favorite food is something, it would try to predict, high chances, I don't know, pizza, or maybe it's tacos, maybe it's sushi. Sorry, my handwriting is terrible, right? And so on. But these are very likely answers, whereas it'd be very unlikely to say, my favorite food is something. My favorite food is it'd be very unlikely to say, my favorite fruit is tree. My favorite fruit is concrete, right? There are a lot of answers that are very unlikely. And it turns out that large language models trained using supervised learning like this, when scaled up to a very large neural network, and when trained on a large amount of data, became kind of the first generation of a large language model. And so one of the major breakthroughs in large language models was really, I think Google and my former team, Google Brain, as well as OpenAI, both contributed a lot to the science of large language models. But with the GPT-3 model, which was published by OpenAI, there started to be this idea that you could prompt a large language model. And in that early generation of a large language model, you would write a piece of text like, a frog and a unicorn made friends, right? So you could make up something like that and then ask, what is the most likely word? Maybe you'll say in, and you say a frog and unicorn made friends in, and then what's the most likely word? Maybe magical. And then given this fragment, a frog and unicorn made friends in a magical, then it could, through this process, predict one word at a time to basically write a story. So the frog and unicorn made friends in the magical forest, and so on and so on. And the way that a large language model could make this prediction is by repeatedly giving it the prompt, the set of words you had started off the story with, together with any words that it already generated, and you just ask it, what is the most likely word? I'll put one more word, you ask it, okay, given this, what is the next most likely word? And so this is the first generation of large language models that started to be really useful, that started to exhibit surprising, incredible behaviors. And then there was a second generation of models, which are sometimes called instruction-tuned models. This is a generation of technology that made ChatGPT possible. And instead of asking it to predict what is the next word, based on text on the internet and other general text sources, instruction-tuned models were trained with examples where you would give it a question or give it a set of instructions. So the instruction could be, give me 3 good names, right, for a cat. So instead of just saying, what's the next most likely word on the internet, in fact, if we were to say, give me 3 good names for a cat, it's quite possible that on the internet, the next phrase will be, give me 3 good names for a dog, give me 3 good names for a new city, and so on, right? But when you use ChatGPT, you don't want it so sometimes if you actually prompt the older generation of language models, you say, give me 3 good names for a cat. It's quite possible that there's a list of quizzes on the internet. Then the next question it could be, give me 3 good names for a dog, or give me 3 good names for my pet lizard. But we don't want that when you use ChatGPT. You want it to follow the instructions. And so the next generation of large language models were instruction tuned. And loosely, what that means is that it was trained on data, whereas examples of conversations where if I say, please give me 3 good names for a cat, I want to just give me 3 good names like fluffy or furry, or I don't know, I'm not good at finding with cat names. But so what the second generation was trained on was, in addition to training on text on the internet, it was trained on text on the internet as well as examples of so-called good conversations, which were initially written by people. And that allows the algorithm to predict if you're trying to be hopeful to follow instructions. Maybe the next most likely word is, fluffy, followed by furry, followed by, I don't know, shark ears, right? And then this became the instruction-tuned generation of large language models, which is what's used in ChatGPT and Bard and Bing text search and so on. So sometimes we call this a base LLM, base large language model. Still very useful, but then the instruction-tuned language models, which became very popular just last November when ChatGPT was announced, lets us do even much more. Now, some caveats. I have simplified the details a little bit. Today, large language models technically